Have you ever gazed up at the night sky and wondered, how do the planets move so precisely? The secret to this cosmic dance lies in the laws penned down by a man named Johannes Kepler over 400 years ago. So buckle up as we delve into the fascinating world of Kepler's laws of planetary motion. Kepler was a German astronomer and mathematician who, in the early 17th century, formulated 3 laws that describe the motion of planets around the Sun. These laws not only revolutionized our understanding of the universe, but also laid the groundwork for Sir Isaac Newton's laws of motion and universal gravitation. The first law, often referred to as the law of orbits, breaks away from the classical idea of circular orbits. Instead, Kepler proposed that planets move in elliptical orbits with the Sun at one of the 2 foci. Imagine an elastic band stretched around 2 nails. That's an ellipse, and one of those nails represents the Sun. This law explains why planets don't always stay the same distance from the Sun. Proceeding to the second law, otherwise known as the law of areas. This law states that a line connecting a planet to the Sun sweeps out equal areas in equal times. In simpler terms, planets move faster when they are closer to the Sun and slower when they are farther away. Imagine a planet as a race car on an elliptical track, speeding up on the curves and slowing down on the straightaways. The area it covers in a specific time remains constant. Finally, we arrive at the third law, the law of periods. This law relates the time a planet takes to orbit the Sun, its period, to its average distance from the Sun, its semi-major axis. It states that the square of a planet's orbital period is directly proportional to the cube of its semi-major axis. This means, for instance, if you double the average distance of a planet from the Sun, it will take approximately 2.83 times, the cube root of 8, longer to complete its orbit. In summary, Kepler's laws paint a picture of a harmonious and orderly universe. The first law tells us that planets move in elliptical orbits, not perfect circles. The second law reveals that a planet's speed varies depending on its distance from the Sun, moving faster when closer and slower when farther away. And the third law shows a relationship between the time a planet takes to orbit the Sun and its average distance from the Sun. These laws, formulated over 4 centuries ago, still remain central to our understanding of the universe. They underpin the calculations that send spacecraft to other planets and predict celestial events. Kepler's vision of the cosmos, a place of mathematical precision and elegant geometry, has stood the test of time and continues to guide our exploration of the vast universe. So, the next time you find yourself marveling at the celestial bodies above, remember the man who unraveled the secrets of their dance, Johannes Kepler. He looked at the stars and saw not just points of light, but a symphony of motion governed by simple yet powerful laws.